Hi, this is a safety discussion for Chem 1A and Chem 1B at San Jose State University. The person talking to you is Karen Singmaster. I'm the Chem 1A, Chem 1B lab and seminar coordinator, and I'm just the chair of the chemistry department. That would be me there. The co-coordinator is Ms. Brenda Serrano. Some friendly reminders up front. I don't want you to forget that at some point there's a green sheet quiz on Canvas. And note that this discussion is a little longer than normal because we had to incorporate COVID in it. Another disclaimer, you might have noticed already, I say some words in a strange way every now and then. My first language is not English, it's Spanish, so every once now and then, if I see a word, I try to revert back to Spanish. What do we do in seminar? We do the quiz for the previous week's lab, and the lab exam, if there is a lab exam that week. We discuss the experiment, data analysis for the experiment, how to do the calculations, and any safety issues associated with the experiment. What we do in lab is we review safety concerns about the lab. We quickly demonstrate any technique that's needed. We discuss any chemical waste management. You then collect your experimental data. If there's any demos, the instructor does the demos. And you work on the worksheet or the report sheet associated with the lab. Realize that many of the report sheets are due at the end of the lab. So that you know what's going to happen next week in seminar, you will first have a safety quiz that you must pass with an 80%, all true and false. And this is an opportunity for an easy grade, a good grade that can help balance off a bad quiz grade from the future. When we talk about experiment 1. Safety rules are in the files in the module, print them and read. I also encourage you to read the seminar and lab green sheet well. So let's get started here. Why do we do this? We don't want you to get hurt. Essential knowledge for all STEM careers. In particular, you're probably asking yourself, why are we doing this when you're not even in lab for Chem 1A, because all of Chem 1A lab is online. This is because all these safety things have to be taught to you multiple times. You have to be trained on how to do them so that when you are employed as a scientist or as an engineer or working in some sort of facility where chemicals are used, which is in many facilities, not just science oriented, just think about, cleaning materials, environmental protection stuff, all sorts of stuff. You have to know safety rules, including your home. There are chemicals you can mix at home that you can do yourself great harm with. In addition, for these last few months, you need to see what happens with the CDC. The CDC, the Center for Disease Controls, for example, tells you what needs to be done to keep yourself safe from COVID. And so you have to learn how to be safe from the virus. So safety rules overall are things all employees have to learn. They're trained for when they start a job. And if they don't know the safety rules associated with the particular job, they can hurt themselves, hurt others. If they don't follow them, they can be fired from jobs. So it's something to consider as you hear us going through these safety rules. First and foremost, safety goggles. You must wear safety glasses or goggles if anyone's doing the experiment in lab. The safety goggles are what we provide in your drawer. Because we have to provide the highest level of eye safety, and every now and then you might have to use a strong acid, and for strong acids in fairly high concentrations, you have to use safety goggles. However, 99% of the time, safety glasses with side shields and up shields, which are sold at, shields that go to your forehead, are sold at places like Home Depot. If you wear glasses, we prefer if you wear glasses than contact lenses. The reason for this is if anything gets in your eyes, we have to wash your eyes at the eye station for 10 to 15 minutes. If you have contact lenses on, then the instructor has to try to fish them out of your eyes, which sounds rather bad, actually. Basic behavior rules: no unauthorized experiments, and never work alone. You don't get to start mixing everything you find in lab together like a mad scientist lab. You could hurt yourself, you could hurt others. You have to do the assigned work. It's not a place to be moving around violently. jumping around, etc. It's a place where you have to think about how you move, because if you bump into someone that has chemicals in their hands, they could spill those chemicals on you or on themselves. That's actually a way we've had accidents before. You can be instructor dropped from a course for not following the safety rules and being a hazard in lab. Notify your lab instructor if there's a fire or accident or chemical spill that's happening in the lab. Realize there are 24 people in the lab, so the lab instructor only has so many eyes, so much ability to look at everything at a given time. If the accident is serious and your instructor seems overwhelmed, call 911. In the event of an evacuation, don't use the elevators, take the stairs, turn off the gas. If you were using gas, take your stuff with you. Take your stuff with you because we never know if we'll even be back in the building. Follow the instructions from the emergency coordinators. Stay away from the building until you're told it's safe to re-enter. And let your lab instructor know you're safe. Hopefully you walked out with your lab instructor so they know you're safe. We have to worry about earthquakes in California, so you find cover, even a light earthquake. You can get to the doorways, you can get under a desk or the lab bench. You can face the inner walls, but stay away from the windows, and then you remain inside until the instructor, police, or emergency coordinators tell you it's safe. Clearly, we would never eat anything in lab, but we have to emphasize that. We don't pipette by mouth. There's no eating or drinking in the lab. You should not apply makeup in the lab. You should not store food or drinks in any sort of chemical equipment like a beaker and things like that. Smoking is prohibited on the entire campus, so that includes lab. Never intentionally taste chemicals. Don't wear rings to lab. Your ring will get damaged or permanently attached to your finger if the right chemical gets in between your ring and the finger. It's an uncommon thing, but it's a thing we do warn people about, particularly as the labs get more advanced. It's best to not have jewelry on in your hands. Learn the location of the eye wash and the safety shower. Now, there is a YouTube video that you're going to be also sent to watch, or you were already sent to watch, that shows you all the safety equipment in the lab. If chemicals are spilled on the skin, you immediately rinse them with large amounts of water. Now, note, most chemicals in Chem 1A and Chem 1B will not harm you, but you need to get them off your hands so that you don't put them in your eyes or in your mouth by error. If you do have a cut, an acid will sting, sort of like putting vinegar or lemon juice on your hand. There are certain chemicals that'll do a little more than that. In particular, a silver solution will leave a dark mark on your skin. It's okay, it's not a big deal. It'll come off as you wash your hands over and over the course of the next few days to weeks. Nitric acid will burn, will damage the first layer of your skin, and that piece of skin will fall off in a few days. Tell your instructor immediately if your skin is reacting to a chemical. Keep extra stuff off the benches and out of the way. Be aware that we're not responsible for your purses or your jackets. If you bring them to lab, put them on the counter and there was a chemical in lab. So that comes next here. Wear appropriate clothes to lab. Don't bring your best clothes to school for Chem 1A lab. We're aiming for minimum skin exposure. Shoes have to cover the whole foot, the whole top of the foot. So no sandals, no open toe shoes, no shoes with little holes on them. That's not a good idea. Do not wear very loose or long flowing clothes to lab. Long hair must be tied up. Your lab instructor can demand that you leave lab because of inappropriate clothing. We encourage you to bring a change of clothes or a lab coat if you want to come dressed to school with exposed skin. So you have to be covered from the chest all the way down. With the exception of your hands and forearms, we're okay with not wearing long sleeves, although many universities will require long sleeves. We understand that it's hot at San Jose State, but there has to be some sort of a sleeve, like a regular t-shirt, not a super small, sleeve, but something reasonable, a couple of inches at a minimum, say 5 inches of a sleeve. Again, let me bring you back to this. If you're not properly dressed to lab, we will kick you out of lab. We won't admit you into lab. In particular, the things we notice are that people come to school in short shirts that are barely covering the middle of their body. And so they just lift their arms a little bit and the belly's exposed. That's not good. Your shirt has to stay covering your body, your skin, when you raise your arms. In addition, people come to school with shorts or come to school with pants that are a little bit short, and then there's exposed ankle. There should not be any exposed ankle. Think about when you throw a chemical, if a chemical falls off from the counter, it's going to hit your feet and your ankles. In particular, consider clothes to be your first line of defense. When an acid falls on you, the acid first has to do stuff, get through your clothes to get to your skin. That buys us time to get you to a shower, so in some way we reduce the extent of damage to your skin. The hoods are used for chemical reactions or processes that generate fumes. Your instructor will tell you about this. Do never intentionally smell lab chemicals. We have to keep the lab doors and windows closed so that the hoods work properly. Don't store equipment in the hood unless the equipment has to be in the hood for some reason or another. And keep the hood sash correct to the correct height as much as possible. Realize that during our 1B experiments this semester, because we hope to have live 1B experiments with students coming to campus, we want the hoods on from the moment you arrive to lab to the end of the day. What the hood is going to do is it's going to more quickly remove aerosols. Right now they're indicating that one of the most contagious way of transmitting COVID is through aerosols. It's what comes out of your mouth when you're talking. The louder you talk, the more aerosols you generate. That's why you're wearing masks. You're wearing a mask from the moment you come to lab to when you leave lab. Again, what you do outside of here is your business, but you're required to come to campus with a mask on. And again, we encourage you to wear a mask the whole time as the county is requesting, but you know, we're not going to be here enforcing it. We just enforce it when you're in lab. So the hoods are going to be on all the time because of this. So please just, if you notice they're not on when you come to lab because you're the first lab in the morning, then tell the instructor, hey, we need to turn on the hoods. Flammable hazards, learn the location of the fire extinguisher and the fire blanket. That's going to be shown to you in the video for the lab. Learn which substances are flammable. Shortly, we'll walk through the diamond to show you how you know if a substance is flammable. Don't heat flammable substances with an open flame. So be aware of this. Don't be bringing acetone close to a Bunsen burner to see what happens. You can smother small fires with a beaker. Remember, a fire needs oxygen, a fuel, and a spark. So once the fire starts, the quickest way to usually turn it off is to remove the oxygen. And so by putting a beaker on it or putting something non-flammable on top of it, you remove the fire. Say, for example, you quickly throw on top of it a heavy jacket or something like that can sometimes work with a small fire. Don't store chemicals in your locker unless told to do so by your lab instructor, which can occasionally happen in Chem 1B. Take only the chemicals you need from the reagent bottles. You do not return excess chemicals to the reagent bottle. Certain chemicals can go down the drain with a lot of water. Others need to be collected in waste bottles. If you don't know what to do, ask. Sometimes students take a lot more than what's read because they go, you know, hey, it said I needed 10 ml, let me take 100 ml. If you do that and you realize, wait, I only needed 10 ml, then you might be able to transfer some of yours to some other classmate's beaker so that they don't have to get it out of the reagent bottle. But again, you do not return the chemical to the reagent bottle. Clean up broken glass with a brush and a dustpan. Don't pick it up by hand. Put it in the broken glass container. Don't put it in the garbage can because then the janitor gets cut. Clean up minor spills with paper towels and water. For large spills, notify your lab instructor. There are occasions that you're cleaning up a spill of a dangerous chemical, dangerous meaning not good for the environment. As such, there might be a bucket in the room that allows you to put those dirty paper towels there rather than us putting them in the trash. The way you can tell what the hazard of a chemical is by looking at the safety diamonds. These are on all the bottles of chemicals we have in lab. Flammability is in red, reactivity is in yellow, health is in blue, meaning health is usually if it's very toxic, and any special warnings. The numbers you will find in the boxes and the diamonds are 0 through 4. So if you have a 0 in a flammability box, it's a non-flammable material. If you have a 2, it's a flammable material. If you have a 4, it's a highly flammable material. We probably won't have it in lab. Typically, we don't have very dangerous chemicals in lab, so don't be surprised if none of them have, 4s and 3s on them. We tend to stick to 0s and 1s and the random 2. Some special warnings include if something's a strong oxidizer, they want to let you know that. We will soon learn in Chem 1A what an oxidizing agent is. Chem 1B, people already know that. The other thing that will go there, if it's something that has to stay away from water. So if we had sodium metal in lab, it would have a W with a bar, a W crossed out to let you know that this material should not get anywhere near water. Okay. General chemistry and chemical information. Every chemical has a material safety data sheet. That's called an MSDS. They are available in the stockroom. This is important to learn how to deal with, and we might consider creating a quiz on it. Because when you start a job at a company and they tell you, hey, you need to pour this chemical this way and do this and do that with it, and that chemical could be, a pesticide if you're working for a gardening company, for example, or it could be some, bleach for, say, you're working for a cleaning company. So please don't take this just to mean it's a chemical company. It is any company that uses chemicals. They have to have material safety data sheets. Those sheets, you have the right to request it, and in it you can read what is the way this chemical should be used, what are the toxicity levels, is it flammable? All the information about the chemical has to be there, okay? So that you are educated on how to use it safely and what PPE is needed. PPE is personal protection equipment. So personal protection equipment, do you need gloves? Do you need a face mask? Do you need safety goggles? Do you need an explosion shield? Does it need to be used in a hood? Is it flammable? All those sort of questions get answered by a material safety data sheet. Clearly, while you're taking Chem 1A and Chem 1B, you'll learn a lot about a variety of chemicals, but we don't use every chemical you will ever encounter at home or at any job you might have. So this is the place where you can get the information that allows you to better determine if you are safely handling and disposing of that chemical. We need you to be a good lab citizen, and this is particularly a case for the Chem 1B people, but we'll get to it at the end. Clean up after yourself, clean the workbench, the lab bench you were using. Make sure those analytical balances get cleaned up. People spill a lot of stuff in them. There are brushes near them so as to help you brush the stuff out from the inside of the balance. Once you brush it onto the counter, then you wipe it down with a wet rag, wet paper towel. Depending on the chemical, that wet paper towel might go into the paper towel basket or in the garbage can. Paper towel, we have a waste disposal for paper towels that have chemicals that are dangerous. So it could go there, it could go in the trash can, a conversation to have with your instructor. If you empty a reagent bottle, then you need to take the reagent bottle to the stockroom, and you can't transport it to the stockroom in a safety bucket. That safety bucket is also used to transfer glassware. to the stockroom if you have to pick up glassware. Do not overfill the waste bottles. If a waste bottle is full, tell your lab instructor. Either you or the instructor will inform the stockroom that it's full, and the stockroom will bring another one to the room. In an emergency, your lab instructor might ask you for help by calling 911, helping with emergency personnel getting to the lab, locating and obtaining emergency or first aid equipment, controlling hysterical classmates, assisting in first aid. Clearly, you have the right to decline to assist. If you're pregnant or have some other health issue that could cause you to get dizzy, cause you to have seizures, it is your personal information. However, it is useful for you to let the lab instructor know about this, because if you pass out in class because of your health condition, we don't know that, and we will assume it was something you did with the chemicals. And so in that case, we're sort of stuck there trying to figure out, what did you do, and did you expose someone else to something? Okay, and so by us knowing, no, don't worry guys, keep working in lab. The student just has a medical condition that caused some dizziness. We take you outside, and we're better informed when calling 911 what to tell the emergency personnel that is what is going on with you. In particular, note a lot of students come to lab not eating. You're on a diet, maybe you skip lunch, maybe whatever. The smells of a chemistry and a biology lab tend to cause people who are already sort of weakened and already dizzy and nauseous, because they're not eaten, to get more dizzy and nauseous. And then they want to attribute it to the lab and not to the fact that they're hungry and or sick. Because of this, it is essential that you don't do that. Please don't come to lab after not eating for 24 hours because you thought it was, you're doing some sort of juice cleanse, and now everything in lab is going to make you nauseous or sick. If heating a test tube, aim it away. Aim the opening of the test tube away from yourself and your classmates. Sorry. Use a safety bucket when transporting glass or chemicals back and forth from the stockroom to the lab. You can't bring in people to help you that are not enrolled in the lab. It's already hard enough for the lab instructor to keep their eyes on 24 people. And remember, it's particularly important to wash your hands at the end of the lab. The chemicals we use in lab can be irritants, caustic to skin, mucous membranes, lungs, or eyes. Now realize that for the most part in Chem 1A and Chem 1B, we don't have anything so dangerous, but we never know if someone is asthmatic, if someone has some underlying medical condition or some underlying allergy that one of the chemicals will set off. So typically that does not happen, but we can't predict if we have a student with such a situation. So you let us know. So again, they, one or two might burn. Most of them don't do anything to your skin. Systemic poisons. Yes, if you eat them, most of the chemicals in lab are poisonous, but we expect that you won't be eating them. They're flammable or explosive. In the lab, we don't have anything that's explosive. However, in theory, you could combine things in lab in a way that you generate an explosion, because we have quite a few different chemicals in lab, not all being used for a particular experiment. The ways that you usually hurt yourself in this course can be by poor transfer or handling of chemicals, being told to keep something cold and in turn you keep it hot. That accelerates chemical reactions. Certain chemical substances can be bad for you. The two in particular I can think of, concentrated nitric acid will burn quite a bit. It'll cause what you would call a first-degree burn. Again, you rinse it off with water. We put some burn ointment on you, but understand that the skin will form a blister and will then scale or scab off. So it's not a big deal. Chemical amounts matter. If you decide to take too much, if you decide to combine too much, if you decide to take something much more concentrated that you were told to take, the order in which you add multiple substances can have an effect. When you add an oxidizing agent can have an effect. Whether you add things at a rate that is inconsistent with what you were told to add it slowly, you decided to dump it all at once into together. You put chemical disposal, meaning you put the waste down the drain when it shouldn't go down the drain, or you put waste that shouldn't be in water, or something like that. And then dilution of an acid, always add acid to water while slowly and carefully. So that means you have a little water in a beaker, and if you're trying to dilute a concentrated acid, then the concentrated acid gets poured into the water. And again, you would be reminded of these things with every experiment, and they're part of every experiment. So it's not like you have to be aware of all this every second. We bring them up again as every experiment comes up. Now, anything left to cover? Yes, we got new safety things for 2020 associated with COVID, right? So in particular for the Chem 1B students who we hope will come to lab, however, some of these things are still important for others to be aware of, you have to wear a mask to lab, and you have to keep it on while in lab, and the mask needs to cover your nose. This idea that it's just to cover your mouth is helpful, your mouth and nose are much better. Maintain social distance. Clearly, you're going to walk by someone when going to the hood or the balance room or something like that, but you're not going to be hanging around, a foot away from someone in a line waiting to use a balance. Wash your hands often with soap. At least wash your hands when you start lab and right before leaving lab, but you end up cleaning so much dishware and glassware in Chem 1B that you'll be washing your hands probably multiple times during the course of the lab. At the end of lab, you clean your counter area with soap and water. If the room has an alcohol spray bottle, spray a little on the counter. Just realize you're not going to soak it down with alcohol. We just want, a little extra bit of alcohol in there to help out. And that, because also that's the way you clean biology labs, we're trying to reinforce it. Typically, soap and water is more than enough for a chemistry lab. But once you have biologically active stuff, then the alcohol is helpful. If you have used a balance or some other equipment, you can spray some alcohol in a piece of paper towel and then gently wipe down the toolbar or the door handle or whatever it was that you touched. Wash your safety glasses or goggles with soap and water when you come to lab if they were stored in your drawer. If you brought them from home and you're cool with it, then you're cool with it. But if they were stored in the drawer or at the end of the lab or something like that, you can wash them off, and that way you've protected them. All right. How to destroy the virus is associated with intermolecular forces. For those of you who took Chem 1A already, the outer shell of the virus is made up of lipids. Lipids are fatty acids and carboxylic acids, like stearic acid was in experiment 11. And so you can destroy that lipid layer by adding soap, because soap is also a fatty acid, and as such the two interact and it tears apart the structure of the virus. Once you tear apart the structure of the virus, the contents spill out and they're no longer effective. Our last slide here, please remember you're going to have a safety quiz through Canvas. The safety quiz opens for a total of 10 minutes. So you have 10 minutes to answer 20 true and false. You must get an 80% or better, or you get to take it again. If we had to take it a third time, then we have a problem, because we're trying to understand. It is the easiest quiz of the semester, and it is about the safety rules we've just discussed, the video you watched, and you can read the safety rules also. Again, safety does matter, particularly now that you're seeing all these things with COVID. It is difficult for some people to accept what, say, the CDC tells you have to do, because you don't understand the science behind it. Once you understand the science behind it, you then tend to get on the program, because wait a second, I need this soap to be able to dissolve the lipid layer of the virus, which destroys the virus and makes it ineffective. It can't do its thing. Realize that 99.9% of the population does not do science degrees. They don't become engineers and chemists and forensic science people and nutritionists. And so Chem 1A, 1B are courses most of them have never taken. And so you serve as someone who can educate others as to the why certain things are done. And so it's important, possibly more now than ever, to have a strong background in chemistry to understand the reasons why certain guidances are provided. The whole thing I discussed with you with aerosols. Aerosols linger for a very long time in stagnant rooms, like, you know, an office or something like that. And their rate of decay doesn't change as a function of time significantly. So if someone's been in a room and they leave and they spoke loudly in a room like I'm doing right now, and someone then comes in 10 minutes later, the aerosols associated with me talking are still there. If on the other hand, you're in a room with turbulent flow, the aerosols disappear in an exponential manner. This is something that will be discussed in Chem 1B in terms of kinetics. You can go to the CDC and see that, for example. And so we're learning the reasoning behind why people, for example, want to be outside instead of inside to minimize the transfer of the virus. These are things that have always been here. There's always been something. It's just that a lot of people don't pay attention. For example, that website below here talks about chemicals you should never mix from at home because they will create a cloud of ammonia that will make you very sick, or a cloud of chlorine. But people don't pay attention to these things sometimes. All those bottles give you safety guidelines on how to do it. And right now there are a lot of people using bleach and disinfectants in an incorrect manner, again, because they don't pay attention to the safety instructions and they're not familiar with chemistry. So this is, again, a moment in history in which understanding science can be extremely useful to you in not only understanding what you're being asked to do, but explaining to others why those things must be done. Thank you for your time. That's the last slide. So we'll turn this off. Bye.